Hi everybody, this is Stephen Pugh. We're going to be doing another video for the City and Guilds Carpentry and Joinery, and we're going to pick up with video number 9. And video number 9 is in this overall chapter, the principles of building construction, information and communication. So we're still talking about foundations at the moment, and as you know, there's lots of different types of building, and different types of building will require different types of foundations. For example, you all have probably been down to London and seen these massive high-rise buildings. Well, of course, they need very specialized foundations, and you may have seen buildings a little bit like our college, and of course the buildings are quite high and they're made of steel and they're made of concrete. So that again is quite a sophisticated form of foundation that's required. And then of course you might have a small house, either a 2-story or a bungalow, and those will need much less sophisticated but nevertheless perfectly adequate and correct foundations for them to sit on. And the first foundation we need to talk about is what's called a strip foundation. Now, a strip foundation is very traditional, and it's the sort of foundation whereby the builder, either by hand or with a machine, digs out a strip in the soil, and that strip is generally quite tight and fairly deep. Sometimes it's 1 meter deep, and sometimes it's about 400 or 500 millimeters wide. And then what they will then do is they will pour concrete into that strip, and that concrete will be one continuous strip of concrete going round the building underneath where all the load-bearing walls are going to be. And that concrete's poured in, and it's made very secure, and that's given time to dry and cure, and then the brickwork is then built on the top of that concrete foundation. Sometimes we talk about footings and sometimes we talk about damp-proof course. Footings are brought up to the level of the damp-proof course, which is the course of the brickwork and underneath the brickwork, which prevents damp from coming up into the building. Okay, it's a damp-proof course. Sometimes below a damp-proof course we may use engineering bricks, and we may use trench blocks. Now, an engineering brick is a brick, a normal brick, but it's cured to a very high level of heat, and that means it becomes completely hard and waterproof. Okay, a special type of clay that's involved in making an engineering brick. A trench block is a large block of concrete, and it can be laid down in, even when it's wet, it can be laid down, and the whole building can be built on the top of that. Okay, now then, what happens then is that other types of foundations can be made. For example, you can have a trench fill foundation, and you can also have an eccentric foundation. Now, first of all, a trench fill foundation is where the concrete is brought right the way up, okay, to where nearly to the ground level, and then from then on blocks are used below the damp-proof course, and then bricks above the damp-proof course and blocks on the inside. An eccentric foundation is a little bit different. It's the same idea. It's a simple trench that's built, but instead of putting the wall in the center of the trench, the wall goes up against the side of one of the sides of the trench. Okay, and that's something that's common. It's something that you'll see on building sites. It's just one of those quirks of a building site. Sometimes these things are like that. So there we are. Now then, the other form of strip foundation is called a wide strip foundation. So again, it's a strip foundation, just the same. It goes around the walls, underneath all the walls, but on this occasion, instead of it being a narrow strip, it's a wider strip. So the trenches are wider, much wider, maybe twice the width, and the concrete that goes in the bottom is just about the same height. It's just that it's a wider foundation. There's all sorts of reasons why these wide foundations are used. Very often they'll have steelwork within the concrete, and this helps to bind them together and prevent anything from cracking. That's the purpose of wide strip foundation. Now, occasionally you'll hear of the word pad foundation. A pad foundation is simply a square block of concrete, quite thick, but not very wide, and it's in a square shape. In other words, it's a pad, and it sits in the ground, and what goes onto the top of it is either a pillar of brickwork, or it might even be a steel stanchion, as sometimes some people call it a column. So a steel stanchion that sits in the middle of the pad, and what the pad does is to spread the load that's coming down through the stanchion. But that's very common. You'll see them around a lot. A lot of buildings will have brick pillars or steel erected stanchions. The next one that we're going to talk about is pile foundations. Now, piles are a little bit like fingers that reach down into the ground, below the ground surface. And as they reach down, you know what it's like if you put your hand into sand, it's okay, it can go in a little bit, it can reach in a little bit. If you put your hand flat on sand, it doesn't push down very easily at all. So what they do with these piles is they push these piles down into the ground, and they go down and down and down until in the end they receive such resistance that the building then can have all of its load put on and its imposed load, and it won't go down any further. So piles are very common. They can be circular, they can be tubes, or they can be concrete blocks. There's all sorts of, they can be concrete put in wet. There's all sorts of forms in which piles can be put down. Okay, now one of the most common forms of foundation, ones that you'll probably see more than any other, is called a raft foundation. Raft foundations are a large concrete slab. If you can imagine, the whole of the footprint of a house becomes a concrete slab, all in one piece and all cured at exactly the same time. This prevents it from sinking into the ground. The wider the footprint, the less it will sink, and so it's very often used where the subsoil is rather soft, and normally strip foundations would be piercing into the ground. So with a wider raft, the raft sits on it like a raft does on the water. A raft sits on the surface. On top of that raft then there'll be the load-bearing walls. Underneath it, they very often will put down hardcore, which is basically stones, and sometimes there's a little clay in it, or very fine finings, and then they'll ram that down nice and tight, and then they'll put the raft on top. So this basically is all the information really that you're going to need to know as a carpenter in relation to foundations. Very often you'll be called upon to assist in foundation construction. You'll need to put your big wellies on and get your big shovel and your gloves, and you have to get stuck in there and move the concrete about and make it nice and level for the foundation. Now, the other subject we need to start thinking about now is floors. And of course, with floors, there's a number of different types of floors. You've got upper floors and you've got lower floors. Okay? And that's what we need to be thinking about next. But we'll come to that on our next video, and we'll actually no, let's carry on for a little while longer, because yeah, we're doing okay. We're not too tired, are we? So this question of floors then, let's see what we can talk about. There's ground floors and then there's upper floors. Ground floor is usually called GF for ground floor, and then upper floors are called level 1, level 2, level 3 and so on. You see that when you're on a lift, don't you? Floors are required to be load bearing, okay, but there are other things about floors, especially with ground floors, that need to be taken into account. I'm going to go through the order of laying a ground floor. The first thing that we have on a ground floor is hardcore. And the hardcore is put in by a big lorry. It's tipped in place and leveled, and then a machine, a tamping machine, either a hand operated one or a small roller, will go over and over and over the hardcore to try to make it as smooth and level as possible. Now, what needs to go on top of the hardcore is a damp-proof course. But you know, these large sheets of damp-proof course, even though they're quite thick, they can be pierced. If you put it over the top of a stone, the stone could pierce its way through. So what's done next is they put what's called sand blinding. This is normally coarse sand. If you looked at the sand under a microscope, you'd see that they're not nice and round. They're actually jagged edges. So this blinding is put down and it covers right over the hard core. And what it does, it makes the hard core smoother than normal, so that when the damp-proof course goes on top, it's not going to get pierced. What we don't want is a hole in the damp-proof course. We don't want water or moisture to be creeping up into the floor. And then once the damp-proof course is put down, we then put concrete on top of that. And that's going to put it right the way down, and that's going to keep the damp-proof course in place. Now the thing about concrete is that it's a large mass. It's a large mass, it's very hard, and it can be very cold. If ever you've been into an old church and you've felt one of the pillars in an old church, you'll realize that they can be very cold, because the temperature in a solid like that can be quite cool, and you don't want to have freezing cold floors in your house. So the next thing that goes on top of the concrete is expanded polystyrene. There's lots of different varieties of insulation, but expanded polystyrene seems to be very common. And then on top of the insulation material, once that's all put down, you then put in a layer of screed. Now screed is basically cement. It's basically mortar that's mixed quite dry. It's dry. It looks like brown sugar in consistency. It can be made nice and tight, but it flows easily. So this screed is put down right over the concrete, and it's a bit of a skill to get that right, but they get the screed absolutely dead level. And then what can go on top of the screed is things like carpet or underlay, and then carpet. Of course, if a floor is going to have some sort of a really good finish, like say it's going to have tiles or it's going to have wood, then you might on top of the screed use a leveling compound. Now this leveling compound is very, very special stuff. It's a sort of a cement, really, a very, very fine cement, but it has latex mixed in with it. You mix it like as if it's a single cream. It's like a single cream consistency, and you literally pour it right into the center of the room, and then as you spread it out, because it's very, very liquid, it runs, and it runs into any little dips, and it makes the floor dead level. This leveling compound is only to the thickness of about 1 or 2 millimeters. 2 millimeters would be too thick, so it's very fine. And it runs everywhere, right across the whole floor. If there's a little hole, it'll fill it. But the main thing is, it makes a very, very smooth finish. On top of that, then you can use tiles, or you can use wood flooring. Okay, so that's solid floors. Let's have a think about hollow floors or suspended floors. In a building, it's very common for people to have floors that are made of wood, but on the ground level. And the way this is done is the joists are suspended on the walls on each end, and in the center of the room, or maybe twice in the center of the room, there will be a small wall. It's called a honeycomb sleeper wall. So it's a wall that has bricks missing occasionally to allow air to pass through it. So therefore, we don't want to be having a floor that sweats or that has lots of water or moisture in it. We want the airflow to be able to pass through it and take away the condensation. But then on top of that, on those walls, there'll be a strip of timber called a wall plate, and then on top of that will be the joists. So the joists are supported at each end by the wall, and then they're sitting on this sleeper wall. On top of those, then we can then put floorboards, and this is the most common way of building a floor in, say, a house, is to have floorboards put on top of joists. Of course, there's other ways of doing this. One of the ways of doing it is to have what's called suspended concrete floor block and beam. So this is a T-beam, but a T-beam upside down. It's a T upside down, so that the bottom of the T sticks out each side, and we literally put the beams in side by side, and then in the gap between the two we drop in some concrete blocks. Of course, this can be set up very quickly. You literally can set it up within an hour or so. You just put the T-beams across the walls and you start putting the concrete blocks in. Very, very quick construction indeed. There's other quick constructions. One of them is what's called a precast floor. So this is a section of floor, maybe say 2 feet or 3 feet wide, whatever it might be, but the complete length of the building, and it comes on a lorry, and the crane lifts the precast floor and just puts it into place, and then gets another one, and within a matter of what, 10 minutes, 15 minutes, you've got a complete concrete floor. All you have to do then is to pour a little bit of cement in the gaps, and that's your floor completed. There's other forms of beams that can be used. There's a new thing called the I-beam. Now, an I-beam is basically just a strand board piece of, it looks a little bit like chipboard, but with very large chips, if you understand what I mean. And each end of it, the top and the bottom, is just a piece of timber, just a batten, but it's set into the I-beam in such a way that they're glued in, they can't move, and these make exceptionally strong substitute joists. Of course, there's other joists as well. There's one called a posi joist. This really is just a 3x2 and a 3x2, and then steel or steel trusses between the two. They're exceptionally light to carry. They are exceptionally strong as joists. Okay, so let's think about some of the upper floors. But before we do that, we need to talk about the walls. There's two types of walls. There's internal walls and there's external walls. And you may say, well, what's the difference? Well, the external walls are on the outside of the building and can be seen from the outside, and the internal walls could only ever be seen from the inside. They are in the dry. External walls often get wet. Internal walls really need to remain dry. And this is why we have in a building 2 walls generally, with a gap between the two. The outer wall, which has all the rain and snow that hits it and the sun, and the inner wall, which remains completely dry because there's a gap between the two, between the wet wall and the dry wall. Sometimes they're called the outer skin and the inner skin. Okay? And inside those walls, there are holes, and those holes are for windows or for doors, and above each hole there is a thing called a lintel. Now what that lintel does is it carries the weight of the brickwork that's above the door. So if you can imagine a triangle of brickwork above a door or blockwork, well, that triangle is the amount of weight that lintel is carrying. Okay, if you took the lintel out, some of the brickwork would fall, but the whole house wouldn't fall down. The brickwork would fall out up until the point of that triangle. So what the lintel's doing then is it's supporting the brickwork or the blockwork that's above an opening. Another thing that's very obvious, may not seem obvious, but it is fairly obvious, is that bricks are not just laid one on top of each other, they actually interlock. So one brick will go halfway across another brick, and then another brick will go halfway across another brick. This is called bond. And there's lots of ways of bonding bricks together in such a way that they actually hold on to each other and become a solid wall. Sometimes we have what's called a solid wall, and sometimes we have a cavity wall. We talked about a cavity wall a moment ago. It's 2 walls that are actually very close to each other, but there's a gap between the two. Sometimes we have in building what's called a solid wall. So this is 2 skins of brickwork that are actually touching. And in fact, not only are they touching, but occasionally there will be bricks that will bridge the gap between the two. And that binds the whole wall together, and it can become exceedingly strong. And then of course we have something else that's important too. Sometimes we have a timber frame that is the main structure of a building, and then we have brickwork that comes up the outside of it, but the brickwork is not taking any weight. It's really for show, It's there for appearances, and it also is a protector for the timber frame on the inside, which carries all the weight. Okay, so then let's think about some of the materials that are used on walls. First of all, we have bricks, and people may say, well, we know what a brick is. Well, a brick is clay, a clay that's put into a particular size, and it's put into a furnace, and in that furnace it becomes cured. It's taken up to a very high temperature, and that clay becomes solid. Okay. In this country, very often bricks are a particular size, 943 is a size in imperial. But the point is, if you go abroad, and sometimes even in this country, you'll find bricks of other sizes. And you'll also find bricks made of clay full of holes. So that's a very interesting experience to come across the ways in which other people in other countries have their bricks. Then, of course, there's blocks. Now, blocks come in lots of varieties. Some of them are concrete. Some of them are made out of tinder. So they're made out of the material that's taken out of power stations. It's cinder. And what they do is they're squeezed together with great pressure, and it produces a block that's very convenient for building with. Of course, another material that's very natural is stone. Stone is a real skill all in its own right to build with. And stone walls look very pretty, they look very nice. However, they do take a lot of skill, and they take a longer time to build. And then, of course, there's the mortar between everything. So the mortar is a very simple thing. It's a 1-to-4 mix of cement and sand. Sometimes, just very occasionally, you'll get a mix in which there's colour put into it. Okay, sometimes you'll get a mortar that is pretty to look at, and sometimes it's even hidden away. It's just one of those things. Occasionally we'll have a special thing on building called no finings. Now, this is a type of concrete in which there's no or very little sand. So it's concrete just the same, but just no sand in it. And it looks a little bit like the inside of an aero bar. It's full of holes. And you say, well, why on earth would they do it like that? Well, it's because what would happen is, if there was a build-up of water behind a wall, how would the water get through? Well, if there's no finings, if there's no sand in the concrete, then the water can just go through it, and it wouldn't push the wall over. So this is one of the interesting things and the varieties of working on building sites. Now then, there's lots of different types of bond. There's Flemish bond, English bond, and stretcher bond. Those are the main three, and pretty difficult for me to show you on a video like this, all the different types, but it's important for you to be able to become familiar with those bonds and to know a little bit about brickwork. We're not expecting you ever to lay bricks if you're a carpenter, but you'd know about it. It's part of the knowledge that we have. Normally when buildings are built today, we have the outer leaf or the outer skin of brickwork that goes up, and then there's a small space, the cavity, and then resting against the inner leaf of the blockwork that's on the inside wall, there would be some expanded insulation. Sometimes the insulation is silvered on both sides, sometimes it isn't. Sometimes the insulation is like rock wool, like a blanket, or like a thick blanket, and these go in along with the building to enable it to become much more insulated. Now, there are certain regulations about building walls. You can't just put a wall up whenever you feel like it, or do whatever you like. Everybody has to do what's required by regulations, and the building regulations specify the amount of heat that needs to be maintained in a building. So houses that are put up today are much warmer than houses from the past. Okay, the other thing that we need to know about is a little bit more about is framing. Framing is where a house is put up made out of timber. Sometimes these timber frames come with already made in a factory, and they're literally taken off by a crane, put into place, attached to the next one, and the whole building goes up very fast indeed. And there's another form of internal wall, which is literally a piece of plywood with expanded foam between it and another piece of plywood on the outside. And now these are very thick. Okay, very thick. They are super, super, super warm. The only thing that it requires is to be just held into place, and it's normally held into place by 6x2 timbers. And then the outer skin of brickwork is merely there to provide protection for this delicate inner wall. When we talk about walls, and we talk about walls within a building, that is internal walls, there's different types. For example, there's prefabricated wall panels. Now these can be made on the floor, or sometimes they're just made in a factory somewhere, and they're brought in and they're erected there and then, and you plasterboard them and you skim it and you've got a building. When I was a lad, I watched films of Canadian people putting up a house in a day. And they'd literally come on 2 or 3 lorries and they'd put all the walls up, and by the end of the day they were plastered and they were decorated, and people moved in that night. So it's incredible how quickly these things can be erected. So a prefabricated wall panel one is one that's made on the floor completely to the right size and then lifted up and put into place as a whole piece and then just attached. There's 2 types of internal walls in the main. There's metal stud walls, which are basically a track of steel and a track of steel on the bottom, and vertical studs of steel. They're very quick to erect. Very often carpenters are asked to work on these types of things. The other one then is a timber stud wall, and timber stud walls are the bread and butter of carpenters and joiners. So we have a sole plate that goes on the floor, a piece of timber. We have a head plate that goes on the ceiling, and then we have vertical studs. And in between the vertical studs, we have noggins. Above a door, we have a head. That is above a door. That's sometimes it's a double head, 2 pieces, and that supports all the frame above a door. The timber that goes above a door vertical is called a puncheon. A puncheon, that's a word we've probably never heard before. It's called a puncheon. So that's internal walling. And then of course wall finishes. Well, plasterboard is the most common thing, but there's lots of varieties of plasterboard. I mean, there's different thicknesses, there's different finishes that are on them. Sometimes they have a recessed edge where you can put tape between them. Sometimes the edges are flat. Sometimes these plasterboards are screwed into place. Sometimes, occasionally, they're nailed into place. And the main point is that there's lots of ways in which these things can be done. And you, of course, with experience, you will develop a knowledge of all the ways in which internal walling is constructed. So there we are. We've come through a long way. I thought earlier that we'd have a break, but no, we've come a long way today. So that's a lot of information. Now, don't forget, you can use these videos for yourself in whichever way. You can play them a bit, make some notes, stop them, have a listen to something again. You can play them all the way through. You can play them through lots of times. Play them through 6 times. Eventually, after 6 times, it starts to sink in, doesn't it? But we look forward to catching up with you on the next video. And we wish you a great day. Bye for now.